Alright, let's start the semester review part 2. So let's look at this, shall we? Let's look at the first slide and see what we've got here. Okay, so we want to identify the intersection of the plane SZX and plane STU. So remember, a plane needs, when we say plane here, we're saying, okay, SVX, SVX. So this is this plane right here on the side. And then STU is this plane here on top. So where do they intersect? They intersect at a line. Remember, planes intersect at a line, in this case SV. Two lines intersect in a point, but a plane intersects in a line. Okay? Name a segment skew. Skew means, again, separate plane. Whoops, I was about to erase that. On a separate plane, not parallel. So, segment skew, like, okay, I see here WY. I can't choose any that would be parallel, nor any that intersect. So, like, say, VW or VU. That would work. ST. That would work. Because these are all that are not parallel. SX. Parallel, that one's parallel. VZ. Notice that I'm choosing ones that are not parallel and also do not intersect. I can't choose SV because that's technically parallel to that one. Can't choose TU because that's technically parallel to that one. So that looks like that's about it. Okay, so kind of keep that in mind. Skew means, like when you say skew, and you might want to make sure you note that definition, it's not parallel and does not intersect. Okay, you might want to make sure you know the definitions of these alternate interior, alternate exterior, corresponding, and consecutive interior, like angle 2 and angle 12. Notice that angle 2 and angle 12 are on the outside of these two lines, so these would be alternate exterior. I'm just going to put here AE. Let's look at the next one. 3 and 5. 3 and 5 would be here and here. Notice they are inside these two lines on the other side of M, so this would be alternate interior, and then 7 and 15, again let me erase, 7 and 15, those right there, they're on the same side, one's inside, one's on the outside, so these are corresponding. Now, consecutive interior would have been like, say, 3 and 8. 3 and 8 together would have been like consecutive interior. Or if you look at a different set of lines, you could have said, like, say, 4 and 9. 4 and 9 would also be consecutive interior. All right, so given that angle M, and we need to make sure you know the properties, not just the definitions or what they look like, but know the properties. Like alternate interior, we know they're the same. Alternate exterior should also be the same. Corresponding should be the same. Consecutive interior, these, remember, consecutive interior will add up to 180. Okay, so given that angle M is congruent to angle, or parallel to angle N, I'm sorry, given M is parallel to N. Oh, I was going to get that right. And measurement of angle 8 is 86 degrees. Find the measurement of angle 13. Okay, you see here, these two are considered consecutive interior. They're right next to each other, and they're both inside. So these two should add up to 180. So then that means if they're consecutive interior, and I can add them up to 180, then I should say 180 minus 86 to get, say, 94, and that should be my measurement for angle 13. Let's see here. Find the values of x and y given that M is parallel to N, and angle 4 is equal to 6x minus 5. Angle 10 is equal to 5x minus plus 8. And angle 9 is equal to 3y minus 10. Okay, let's look. 4 and 10, those are alternate interior angles. Those should be congruent. So we should be able to say, like, say 6x minus 5 equals 5x plus 8. Variables to the left, numbers to the right, and that should get you that x is equal to 13. Okay, Measurement of angle 9, well, the 4 and 9 are consecutive interior. Okay, so that means they add up to 180. So that one's going to take a little bit more space, but what would happen there is that you would see a measurement of angle 9. Here, let me erase this for a second. So I would put the 13 here and get 78 minus 5 is 73. So I'm saying that 3y minus 10 plus 73 is equal to 180. So that would give me 3y plus 63 equals 180. And then you would subtract 63 and then divide by 3. And let's see what we get. So when I subtracted 63, I got 117 divided by 3, and I got y is equal to 39. So notice here we had to put the x back in to find that angle, but then once we found the y, we were okay. Okay, so be prepared for something like that. You will probably have something like that. Boom, next thing. Whoa, okay, hold up. Okay, so for the next ones, we're doing slope of the line. So all you got to do there is well, let's just do the slope. So how do you do the slope? You just say subtract the y's over subtract the x's. So now here I'll show you what I did. I went ahead and said the y is on top, the x is on the bottom, and I got 915, which was 3/5. Now you could have typed this in with your calculator, again pressing Control Divide, and it would go straight from here to here. So that's up to you. Now notice here I did the y2 first, y1 second, but on this one I do the first number first and the second one second, which is what I normally do. You'll get the same answer either way. You just got to make sure you put the numbers in the correct order, make sure you put a minus in between, and no matter what, you should still get the same answer. Okay, so don't worry too much about those. You might want to make note of parallel and perpendicular lines. Put that on your note sheet. Parallel, again, is same slope, so if slope of 1 is 2, the parallel one would also be 2. Perpendicular is opposite reciprocal. If slope is something is 2, then its perpendicular would be -1/2. If something was -2/3, this perpendicular would be +3/2. So just kind of keep that in mind. Add that to your note sheet. So how do I compare these and how do I decide if they are parallel or perpendicular? Well, I just start doing the formula. So I take the first two, find the slope of those, take the next two, find the slope of those. In this case, I can't read. Slope is 4. And then the second one, I am going to get the slope is, I don't know, let's find out. 15 divided by -5 is -3. So that one would be neither, no. Anyway, so the next one is 6 minus 2, -5 minus -3, 4 minus -2 is -2, 10 minus 4, 2 minus -1, 6 minus over -3, which is -2. See, those two are the same, so that one's parallel. You look at the next one, and you subtract those two, and you end up getting perpendicular. Notice here on this one, -4 minus 12 is -16, 1 minus 5 is -4, and it gives me a 4, but the next one gives me 1 over -4, which would be perpendicular. They're opposite, and they are reciprocals. Alright, so then how do I determine if something is a slope-intercept form? You might want to make sure you have slope-intercept form, mx plus b, point slope form, y minus y1 equals m minus x1. What I have underlined are where numbers are going to go. Okay, so these things will like the m and the b would disappear, and you're going to put numbers in your place. For example, on number 34, if the slope is 7 and the y-intercept is -8, then I would say y equals 7x. Notice the m goes in front of the x minus 8. I could put plus -8, no big deal. 35, you've got a point and a slope. Okay, a little unexpected. So I'm going to put notice y with y, x with x, slope in the middle. Oh, that's so hard. Okay, now notice minus and negative becomes plus 14 or plus 4. So then I multiply by -4. -4 times x is -4x. -4 times 4 is -16. Add 8. So to go from point slope form to slope intercept, all you got to do is move it over. Now, keep in mind, there could be questions that ask you just for this right here, and you don't go any further. So make sure you know which one they're asking for. And then finally, the 36, you've got one that's like slope intercept, or they give you x intercept and y intercept. That one sounds hard, but keep in mind this. The x-intercept is -5, 0. It's always the x number, 0. The y-intercept is 0, y, or the number. And so then you do your slope, and then you can put that in, and you've already got the y-intercept. So once you have your slope and your y-intercept, you would have your answer, -2/5 x plus 2. So what I would make note of, just in case you get this question, if you get an x-intercept, remember, it's always going to be that number that they gave you, 0. The y-intercept, you can convert it to a point, or think of it as a point, as 0, whatever number they give you. So just kind of remember that. And that should help you with that. All right, let's look at some definitions. Make sure you know your orthocenter, incenter, circumcenter. I would add those definitions into your note sheet. The definitions that are right there will work. If you want to add properties about them, that might be good too, because we're going to make some note about those. So here you can see that the incenter is number 37 was A, the incenter, the point of concurrency for angle bisectors. Number 38 was C, the centroid is the point of concurrency of the medians. Number 39 was D, the point of concurrency of the altitudes of the triangles is your orthocenter. And number 40, which is say the point of concurrency of the perpendicular bisectors, is B, your circumcenter. Okay, and now we'll stop that one for part 2, and I will give you part 3 in just a little while. Thank you so much for your time. Y'all are being excellent. Keep it up.